Good afternoon. I welcome you to the session of experimental methods in fluid mechanics. So today we will discuss about the aneroid barometer, and then we will briefly discuss about the diaphragm and the bellow gauges. So we have seen in my last lecture that the aneroid barometer is very important because this barometer allows us to couple a measurement of atmospheric pressure with a gauge pressure measurement for most of the applications. So today we will see how we can measure pressure using aneroid barometer, and to start with I can tell you that this aneroid barometer is essentially a well-type manometer with vertical seal arm, and we will see its constructional features through a schematic depiction. So now I will try to draw the schematic of an aneroid barometer, and then slowly we will move to discuss about its operational principle, and then we will see how we can measure pressure using this barometer. So aneroid barometer is basically what I said, that it is a well-type barometer with a sealed, with a vertical sealed arm. So if I draw the schematic, so today we will discuss about aneroid barometer. I will try to draw the schematic. It is oil type manometer So this is the schematic depiction. It is having a vertical sealed arm, and now we will try to see the dimension of the seal arm and what are the other features of this aneroid barometer. Say this is A1, that is cross section area of the well type manometer well, and this vertical height is H. Say this H is the vertical height of the seal arm. So say this is H, and this is the atmospheric pressure P atm, this is also P atm, and the cross section area of this sealed arm is A2, and this is A1 for the well, and this is the height H. This portion, which this empty part or this blank portion, which is this portion containing saturated mercury vapor, which is, and pressure of this vapor is negligibly small in comparison to the atmospheric pressure, right. And what we can see from the schematic, that the oil is exposed to atmosphere. So the oil is exposed to atmosphere, and this H is the height of the mercury in the vertical arm and this is essentially a measurement of the, this is essentially the, or this is the height h is a measurement of the atmospheric pressure. So, this is a measure of the absolute atmospheric pressure. So, these three are the important point to be noted. These three are the important points to be noted, right. This is a well time manometer which is having a sealed vertical arm. Top a portion of the vertical arm is filled up with saturated mercury vapor and the pressure of that portion is negligibly small as compared to the atmospheric pressure, and the well is exposed to atmospheric pressure, that is what is clearly seen from the schematic, and the height h is measured and this h is a measure of the absolute atmospheric pressure, and one scale should be calibrated along the vertical arm through which we can measure the distance traversed by the mercury. Now, this is essentially this cross sectional feature of an annuated barometer, and if we can recall that we have discussed, we are fortunate to have this because fortunately this annuated barometer allows us to measure, rather allows us to couple a measurement of the atmospheric pressure with a gauge pressure measurement for most of the applications. Now, this type of mercury barometer of these types are very commonly used and are available at a relatively low cost. So, I can write that this type of mercury barometer is commercially available at relatively low cost. One important point that I will mention here, that one should take every effort to use temperature correction at each and every measurement. So, I am writing that one should make every effort to use the temperature and latitude correction supplied with this manometer. So, this is important, one should make every effort while using this mercury manometer, that is annuated barometer. Now, if we go back to my previous slide, here this column of the liquid mercury in the vertical arm, that h height, that we need to measure. Now, this column will have a graduated scale fixed in position. So, I am writing this vertical arm has a graduated scale fixed in position. Number 2 is when requires I can write in a bit different way that this vertical arm has a graduated scale fixed in position because we need to measure height, and this measurement which requires that the instrument be zeroed for each run. Why? This is the important point that I am mentioning here. Why it is important? Because we need to be vertical arm is there, vertical arm or graduated scale is there, which is fixed in position, but this requires that the instrument must be zeroed for each run. That means it indicates that, or I can write that, because level of the well will certainly vary with height of the height of the mercury in the column. So, for each and every run we must ensure that the instrument must be, that scale position must be zeroed, because the level of the well will certainly vary with the height of the mercury in the column. So, this is the aneroid barometer, and by knowing the height we can tell what is the absolute atmospheric pressure, and height we can measure using the scale which is fixed with the vertical arm. Now, we can move to see another two important types of pressure measuring instrument is the diaphragm and the bellow gauges. So, diaphragm and bellow gauges. These two types are also there to measure pressure, and of course they find applications in different this kind of diaphragm and bellow gauges find applications in different areas. So, again I will tell you that these pressure gauges work on the principle that a structure will deform under the application or when a pressure difference is applied. So, till now we have seen that we have seen U-tube manometer, inclined well time manometer, and finally aneroid barometer, and we have seen in all these three instruments we have mercury, and the change in height of the mercury essentially used to measure pressure. Now, in the aneroid barometer we have seen that the top portion which contains mercury vapor, but the pressure of the mercury vapor is negligibly small as compared to the atmospheric pressure. So, we have ignored that. So, by only measuring the height of the mercury column in the vertical arm we can measure the absolute atmospheric pressure. Now, diaphragm and the bellow gauges, these two types are again used to measure pressure in different applications, but the working principle of these two different gauges are directly related to the fact that the structure is there, and that structure will deform under the application of pressure difference. So, I can write that this pressure gauge these pressure gauges work on the principle of that a structure will deform when a pressure difference is applied. So, this is the principle by how these two instruments, these two gauges work. Now, construction wise they are bit different, but they can be constructed to measure a wide range of pressure from quite low to very high. So, construction wise these two gauges are not same, but they can be constructed to measure pressure for a wide range starting from a quite low to very high. So, these two gauges can be constructed, these gauges can be constructed to measure a wide range of pressure, to measure a wide range of pressure from quite low to very high. I will discuss them one by one, and when I will be discussing diaphragm and bellow gauges, I will draw the schematic diagram essentially to have better understanding. We have seen the working principle, then we have seen that these gauges can be constructed to measure a wide range of pressures starting from a quite low to very high. Not only that, these two gauges also enjoy an advantageous feature. So, what is that? That is that I am writing here, rather I can write in the next page, that advantageous feature of these two gauges, that they usually produce an electrical output proportional to the pressure that can be used in a control circuit. Control circuit or be digitized for computer processing. So, this is the advantage these two gauges have, that they usually produce an electrical output which is proportional to the pressure that can be used in a control circuit or be digitized for the computer processing. So, knowing this, now we will see the schematic of a diaphragm gauge, and then we will come to see the schematic of the bellow gauges. Rather, we will take one example, and then we will see how we can measure pressure using the diaphragm and the bellow gauge. So, I am now drawing the schematic of a diaphragm gauge. Diaphragm gauge. So, if I draw the schematic, differential pressure transducer like this. So, we have and so this is say P1 and this is P2 and this is diaphragm. This is diaphragm, and so difference in pressure is P1 minus P2. That is what I said at the beginning, that is what I said in the beginning, that these two gauges work on the principle that there will be a deflection, right, when a pressure difference is applied. So, now the pressure difference is P1 minus P2. Now, because of this pressure difference there will be a deflection of the diaphragm. So, because of this pressure difference we have seen there is a diaphragm. So, there will be a deflection of the diaphragm, right. Now, this deflection will be sensed by the displacement, suitable displacement transducer. This deflection will be sensed by the displacement transducer, and this displacement can be converted to the electrical signal. Now, this can be converted to an electrical signal. So, this is clear that this gauge is having one diaphragm, that is what I said in the beginning. The deformation of the diaphragm will be there if we apply a pressure difference. The deformation will be, and because of this deformation rather there will be deflection of the diaphragm, and that because of the deflection there will be displacement, and that displacement will be sensed by the displacement transducer, and that displacement can be converted into the electric signal, and we will measure the electric signal in the as a output. Now, this is the diaphragm gauge. Now, this deflection how can we measure? So, deflection of the diaphragm can be measured, and that will be sensed by the displacement transducer. This deflection of the diaphragm, this deflection can be measured, deflection can be measured by, or I can say using strain gauges or capacitance changes, or which we know commonly, that is known as LDVT, that is linear differential variable transformer. That is LDVT. So, diaphragm gauge, if we apply pressure difference, there will be a deflection of the diaphragm. The deflection of the diaphragm can be measured using strain gauges, or by measuring the change in capacitance, or by using a linear differential variable transformer. If we measure the deflection, that will be sensed by the displacement transducer, and then equivalently if you can convert into the electric signal, and which is the output of the device, that is the measured pressure difference. So, this is the operational principle of a diaphragm gauge, and again I am telling this gauge is used to measure pressure difference, which is of course, as we said a long back, that in most of the fluid dynamic applications we are interested in to measure gauge pressure, not the absolute pressure, while in most rather all the thermodynamic applications we are interested in to measure the absolute pressure. So, this gauge pressure, that is the pressure difference, that is what we have defined in one of my lectures, that what is absolute pressure, what is gauge pressure, that can be measured using this diaphragm gauge. Now, next I will discuss about the bellow gauges. I mean, we will discuss taking a typical example and showing a schematic depiction of the bellow gauge. So, bellow gauge, again if I draw the schematic, then like this. So, this bellow gauge, this is schematic depiction of a bellow gauge. Again we can see that it works on the principle of a displacement or deformation of a structure when you apply pressure difference, that is P1 minus P2. Now, we can see that here this is a typical bellow gauge, and the schematically I have drawn here. Now, a bellow gauge is, and I am writing a few lines about this, then I will explain. A bellow gauge is an specially constructed chamber that expands when pressure applied to its pressure port. So, this is pressure port, and when you apply pressure at its port, so when you apply pressure at its port, then it is a specially constructed chamber, and that chamber will try to expand upon experiencing this applied pressure, and we have to measure now something, so that we can now measure the pressure difference as a function of something, that is what we will get from the bellow gauge. Now, we have seen that we have written a bellow gauge is an specially constructed chamber that expands when pressure is applied to its pressure port, where I said that something we need to measure, that we will measure the expansion, where the amount of expansion is a function of pressure. So, this amount of expansion is a function of pressure, and these are the bellows, and with time it will expand, that is what we have seen, that we have drawn a few lines. So, with time it is expanding. Now, the arrow shows the movement of the bellows under the application of pressure. So, now this displacement of bellows, that is what we need to measure, that is what is the expansion of the chamber. Now, this expansion we have to correlate, and that is with that expansion we need to correlate with certain quantities, so that we can measure, because expansion is a function of the pressure. Now this displacement of the bellows, that can be converted to an electric signal. That is what we have seen for the last case as well. So now if we convert that displacement to an electric signal, then from there we can measure the amount of expansion, and which will give us the measured pressure difference that we have applied. That is the gauge pressure essentially. So now another one important thing is that these gauges can be constructed to have an expansion, and that is proportional to the pressure, or can be calibrated empirically. So I can write that these gauges can be constructed in such a way that we will have expansion. That means the constructional feature of this gauge will allow to have expansion of a system, and by measuring the expansion of the system and converting that measurement into an electric signal, we can measure the gauge pressure. So provision should be there, rather these gauges can be constructed to have an expansion, Not only that, provision will be there to have an expansion when we apply pressure at its port. So the gauges can be constructed to have expansion. Not only that, this expansion is proportional to this expansion that is proportional to pressure, that is proportional to the pressure. If it is proportional to the pressure, we can directly get. If it is not proportional to the pressure, that expansion, then we can calibrate empirically to have the measured value of the pressure, that is proportional to the pressure, or can be calibrated empirically. So these are the important points that we should know about the working principle of a bellow gauge. That first of all, this is a bellow gauge. First of all, a bellow gauge is an specially constructed chamber, and that chamber will have provision of expansion under the application of pressure that we would like to measure. So when we apply pressure at the port, the system will allow us to have the design will be such that a system will expand, and that expansion will measure, and the expansion can be proportional to the pressure, so that we can get direct measurement, or if the expansion is not proportional to the pressure, then at least the expansion can be calibrated empirically to obtain the pressure. That is what we are interested in. So today what we have seen, that today we have discussed about three important pressure measuring instrument. One is the aneroid barometer, where we have seen that we have mercury, and the aneroid barometer is essentially a oil type barometer, where it is having extra one vertical arm, sealed arm rather, and atmospheric pressure allows to move mercury into the sealed arm, and the sealed arm will have a calibrated scale fixed with it, and by measuring the height we can directly measure the absolute atmospheric pressure. And we have seen that we need to have temperature and latitude correction, and for each and every run we need to make sure that the instrument must be geared, because the that is what we have seen, that level of the oil will certainly vary with the height of the mercury in the column. Next we have discussed about the diaphragm and bellow gauges. Diaphragm and bellow gauges, they are working on the principle of that a system will rather deform when a pressure difference is applied. In a diaphragm gauge, one diaphragm is there, and when we apply pressure difference, diaphragm will deflect. The deflection we will measure using either using strain gauge, or by measuring the capacitance change, or by linear differential variable transformer LDVT, and then we can measure that displacement that will be converted to electric signal, and from there we can measure the pressure. And finally we have discussed about the constructional feature of a bellow gauge, and we have seen that the bellow gauge is an specially constructed device where if we apply pressure at the port, the gauge will have a system that will expand, and while it is expanding we will measure the displacement. Now, so provision will be there for the expansion of a system if we have that expansion is directly proportional to the pressure, we can directly get it, or if it is not the case, that at least the expansion that is what we are measuring, that can be calibrated empirically, so to know the pressure that is what we are going to measure. These three pressure measuring devices or instruments, we have discussed that these are used typically to measure, rather is to measure a wide range of pressures, basically from a very low to very high. I cannot say from very low, but from quite low to very high, but we need to know that if we need to measure pressure which is very small, then whether the devices instrument we have discussed so far, we can measure pressure using those devices or equipment, that is fine. If we cannot measure it using those devices, then what will be the extra or additional feature to measure, to be equipped with a device to measure such a low pressure, and also their working principle. So we will discuss that aspect, rather how we can measure low pressure using other pressure measuring devices or instrument, and we will see to measure the low pressure what are the constructional features there, and whether these constructional features are different from those what we have seen in the manometer, inclined oil time manometer, and this diaphragm and bellow gauges. So with this discussion I stop here today, and we will continue our discussion in the next class. Thank you.